Okay, so there's really two different ways to solve exponential equations. If you have exponents on each side, then hopefully you can get the bases to be the same and then equate your exponents. If you don't, then you're going to have to solve. You're going to have to use the inverse operation of an exponential function, which hopefully you know by now is a logarithm. So to undo an exponent, you have to take a log. So we'll see a couple of examples of each. So this first one here, I'm noticing that I have exponents on each side. So I'm going to go ahead and try to get the bases to be the same. So I'm looking at the bases as a 4 and a 1/16, and I'm saying, okay, I can totally make those the same. I can change them both into a 4. So I'm going to leave this as 4 to the x, and I'm going to change 16 into 4 to the negative second. And I'm changing 1 over 16, sorry, into 4 to the negative second. I'm making that exponent negative because I'm going from a fraction to a whole number, and then 4 squared is 16. So that's where that negative 2 is coming from. And when I do that, I want to go ahead and change this into x plus 3 in parentheses. So that's going to be super important because I have to make sure that I distribute that negative 2 to both the x and the positive 3. So now that I have the same bases, I can go ahead and cancel those out, and I can equate my exponents. I can say, okay, x equals negative 2 times x plus 3. And then I'm going to just solve that equation. So x equals negative 2x minus 6. Go ahead and add 2x to each side. So then 3x equals negative 6, which means x is going to equal negative 2. This next one, I also noticed that I have exponents on either side, and I have a 9 and a 27, so that means that I can totally make those bases the same. So I'm going to change this into a 3 squared. So 9 is going to become 3 squared, and then I have this 8 minus x. So that exponent that was already there, it's important that we put that in parentheses. And then equals, I'm going to change 27 into 3 cubed, and again, put that exponent in parentheses, x minus 3. So now that the bases are the same, I can go ahead and cross them out, and I can set my exponents equal to each other. So 2 times 8 minus x equals 3 times x minus 3. Distribute the 2 on the left, 16 minus 2x. Distribute the 3 on the right, 3x minus 9. So now I'll go ahead and, I don't know, add 2x to each side. That seems nice because I'll keep my x's positive, but you know how to solve things like this. So 16 equals 5x minus 9. Go ahead and add 9 to each side. So 25 equals 5x, which means 5 will equal x. And those problems are easy peasy. This next one, I don't have exponents on either side. In fact, I only have exponents with one of my terms. So I need to think about getting the term with the exponent by itself. So I'm going to do that by adding 2 to each side. So now I'll have 2 to the x minus 1 equals 32. So when I have only exponents on one side, what I want to think about is getting this exponent out of the exponent and bringing it down. So I need to use my inverse properties, and I need to say, okay, I need to take log base 2 of 2 to the x minus 1. And whatever you do to one side of the equation, you have to do to the other. So log base 2 over here of 32. So the reason why I'm doing that is because now I have the same base here. Those are going to cancel out, and I'm going to be left with x minus 1 equals log base 2 of 32. This is a number. You should type that in your calculator. So that's really, you're going to type in your calculator log of 32 divided by log of 2. When you type that in your calculator, you should get 5. So add 1 to each side, and now we know x equals 6. Now some of you might be saying, Ms. Campos, I totally could have made a 2 and a 32 into the same number. And that's true, but you can't. Like if that was a 33 and not a 32, it wouldn't work like that. You'd have to do it the way I just showed you. If it was a 35, if it was a 36, all of those things. So if you do notice that you have an exponent only on one side, but you are able to change the base to be the same, you can do that also. So let me show you that real quick. We have 2 to the x minus 1 equals 32. I can go ahead and change that 32 into 2 to the 5th power. Because, hey, log base 2 of 32 equals 5. And now that I have the base 2 on each side matching, I can go ahead and cross those out, equate my exponents, x minus 1 equals 5, and get that x equals 6. So notice we're getting that same answer either way that you're doing the problem. But sometimes you're going to be forced to do it this way on the left like we did in our calculator. All right, so this last one here, let's go ahead and see for E. Okay, remember E is Euler's number, so the negative 0.3x minus 7 equals 13. So before we can do anything here, we got to isolate that exponent term. So the E has to come by itself. I'm going to go ahead and add 7 to each side. So 4e to the negative 0.3x equals 20. Now, I only have one exponent here, so I am going to have to undo exponents using logs, and before I can do that, I have to get the exponent base exactly by itself. The 4 is not part of the exponent base, so I have to divide by it. Even if that means that I'm going to get a negative, or not a negative, a decimal over on the right-hand side, sometimes you will. You just got to go with it. So now at this point, in order to undo that base e, I have to think I've got to take the log of each side. Well, log base e is really what? Think about it for a second. It's really natural log, so I'm going to take the natural log of each side. Well, the natural log of 5 is a number, and you get that number from typing it in your calculator. Over here, the natural log of e, those are inverses. Those cancel each other out. So now I'm going to be left with negative 0.3x equals whatever the natural log of 5 is. I really recommend that you leave that in your calculator. So type it in your calculator, natural log of 5. You're going to see you get a whole string of numbers, like 1.609437912. Leave that in your calculator and then divide by negative 0.3. And that's going to give us our most accurate answer. The directions are telling us to round to the nearest thousandth, so that means 3 decimal places. So I should get x equals negative 5.356. If you do have to round prematurely, if there's some reason why you can't leave the natural log of 5 in your calculator before you divide, you should round to, I don't know, 5 or 6 places, and then round your final answer to the 3 decimal places. Okay, so this is not on your notes, but it's totally worth your time. You know, when the teacher adds an extra problem, it's definitely something you should take into consideration. So here I have exponents on each side. Now I told you that when you have exponents on each side, you can equate them. You got to get the same base and you can equate them. Well, unfortunately, there's no way to get 10 and 2 to become the same base. So we've got to get these exponents to come down a little bit. So what I'm going to do is I'm going to go ahead and log each side. So I'm going to log each side with log base 10 because I have a base 10 right here. I could use base 2 if I want to. It doesn't matter. I'm just going to use log base 10 because why not? So now I'm going to have log base 10 of 10 to the 3x minus 8 equals log base 10 of 2 to the 5 minus x. So here, log base 10, remember there's a little teeny tiny 10 right there, so those are going to cancel out, and now I'm going to be left with 3x minus 8 equals log 2 of 5 minus x. Well, thinking about our properties of exponents and our properties of logs, we can take this exponent and we can bring it out as a coefficient. So we've got now 3x minus 8 equals 5 minus x. So I'm going to put that in parentheses because that's a whole group together, times log of 2. Well, this right here, that log of 2, that's a number. So you need to type that in your calculator right now, and you need to round. So I'm going to go ahead and round to 4 decimal places. So log of 2 is 0.3010. So we can just go ahead and say 0.301. So now, what does that mean? Well, I've got 3x minus 8 equals 5 minus x times 0.301. So now I can solve this. This is an equation. This is a simple equation to solve. I'm going to go ahead and distribute. So I'll still have 3x minus 8 over here. I'm going to take 5 times 0.301 and get 1.505. And 0.301 times that negative x is negative 0.301x. Now just go ahead and solve. Add 0.301x to each side. Add 8 to each side. Moving up here now. So now I have 3.301x equals 9.505. Go ahead and divide by 3.301. And we get that x equals 2.879. So So noticing here, we weren't able to get the bases the same, but we were able to do a little wiggle waggle and make this work.